Okay, 3-4 quadratic functions. We're going to figure out how to graph them using all of our transformations. Okay, so right here it shows you what the standard form of an equation is, of a quadratic equation. And a quadratic equation is just an equation with a degree of 2. So it's a standard form, or sometimes they call it the general form. And then here is your vertex form. And the reason that they call it the vertex form is because your h and your k are going to be where the vertex is. It's going to be right here. And then your axis of symmetry is just solving for this. So that's going to be this part right here, right down the middle. That's why x minus h equals 0. Remember, that's in the inside. When it's on the inside, then you want to go ahead and solve for it. So x equals h. Hence the reason that's your axis of symmetry. Something really important to remember is whenever you're graphing, there's an order to do it. And so the first thing that you should do is you should do any stretch or shrink. That's the first thing you do. The second thing you do is any reflections. And then the third thing you do is when you do your translations, up, down, left, and right. Okay, this is important. It's going to make a difference on how your graph comes out. Okay, so let's look at this first one. We've got it in a good form. It's in the vertex form, which means we know what the vertex is. The first thing you do, and I'm going to use black, the first thing you do is you graph the parent function. And this is our parent, This is our parent function. So x is 0, y is 0, x is 1, y is 1, x is 2, y is 4, and here, and then x is 3, y is 9, which is up here somewhere. So here's our original, our parent function. Okay, now remember I said there's a certain order you need to go in. So the next thing we need to do is we need to figure out what to do here with the 2. So remember the 2 is on the outside, which means it's going to be vertical, and it's going to do exactly what you think. It's going to stretch it, which means it's going to affect your y values. So wherever my y value is, I need to multiply it by 2. So here in the center it's going to stay the same. Here at 1, it's now going to be at 2, and same here. At 2, my y value was 4, it's now going to be at 8. So let's stretch that up to 8. So now this is doing our stretch, that's the red. Okay, now next thing we need to do is let's do any shifts. So I need to, the 4 on here means I need to go up 4, and the 3 means I need to go to the right 3. But if you think about it, that's the vertex, so that kind of tells me where my vertex is going to be anyways. So if this is here, right, that's my vertex now. So this one right here needs to go up 3 and over 4. Okay, same with this point here, which is going to go right here, and then you're going to have the other one, let's see, my red one, which was up at 8, so it's going to go up something like this. So it's like I peeled that red one off and put it where my vertex is at. That's another way to do this. Okay, so the 2 stretched vertically, so that's the y. The 3 went right, and then I guess I should put arrows, and then the 4 went up. And since we have our vertex is at 3, 4, and our axis of symmetry is x equals 3. Okay, so this is the property of the quadratic function. What it does is it kind of gives you an overview. So think about what you're given here. Here you're given the vertex, and you need to think about that A, which is going to be a stretch or a shrink, right? And one other thing you need to think about is, well, let's look at the vertex first. The vertex is where your graph is going to start. And then don't forget, when you solve this part here, it gives you your axis of symmetry, which is right here. Okay, so that takes care of these two. Now, for the number that is in the front, the A, if it's positive, then your graph, here we go, if it's positive, your graph opens up. If it's negative, your graph opens down. This is important because if it's positive and your graph opens up, that means that vertex is where your minimum of that graph is at. And if it's negative and your graph opens down, that means that vertex is the maximum of your graph, which is going to affect your range. Your domain, right here, we've done forward, your domain is always going to be all real numbers, right, if you're going this way. But your range is going to depend on that A and any transformations or translations that have been made. So the range here would go from wherever your K is from your vertex, so here's my K, to infinity. Now, if it's negative A in the front, that means wherever your K is, right, because remember range is Y, which is the K of your vertex, then it's going to go from negative infinity to that K, whatever it is. So remember, you can't include infinity. So the H is what translates it left and right, and the K is up and down, which is why the H is on the inside, so it's horizontal, and the K is on the outside, which is up and down. Okay, so finding the vertex of the parabola. Now, guess what we get to do? Completing the square again. So remember when we did that before? So let's go ahead and get this started. I'm going to use blue. Okay, so we've got f of x is equal to 2x squared minus 8x plus 4. So the first thing what we need to do is we need to go ahead and separate out this part, because that's where we're going to complete the square. And remember, with completing the square, you want a 1 in the front. So let's pull the 2 out. So now we've got x squared minus 4x plus something plus 4. Okay, so we got to figure out what that something is. And so remember, what we did is we took negative 4 divided by 2. So we took our b divided by 2 and squared it. And then we put that on the other side of the equal sign. Negative 4 divided by 2 squared. Remember, whatever we do on one side, we have to do to the other. The only thing you have to worry about, though, is remember that this 2 belongs with this. So make sure you put the 2 out here with this. Oops, sorry. Make sure there's a, right there, there's a 2. So now we've got 2 times negative 4 over 2 squared is equal to 2. And remember, this is x squared minus 4x plus 4 plus 4. So I'm going to factor the bottom. So let's go ahead and take care of this. Negative 4 divided by 2 is negative 2 squared is 4 times 2 is 8 equals 2. And this is x, oops, not plus, x minus 2 squared, right, quantity squared, plus 4. Now, we want this here to be just f of x, so we're going to take that 8 over. So f of x equals 2, x minus 2 squared, and if I subtract 8, I get negative 4. So my vertex is going to be 2, negative 4, and my axis of symmetry is going to be, solve the inside, x equals 2. Okay, so let's get started on this one. It says first we need to complete the square to find the vertex form, state the vertex and the axis of symmetry. So let's do that first. But I'm going to change something. I'm going to change this to negative 1/2 x squared minus x plus 2. And you're going to see why, because it's easier when you factor something out. Now, I need to separate these and pull out a negative 1/2. So I've got x squared. Now, negative 1/2 times what gives me a negative 1? Times a positive 2 plus whatever that is plus 2. Okay, do it again. Negative 1/2 times 2 gives me negative 1. That's why it's that. Okay, now let's do the completing the square. So I go 2 over 2 squared. And don't forget, I need to put that on the outside here as well. Didn't leave myself room. So it's going to be 2 over 2 squared. And the negative 1/2 goes with it. So now I've got negative 1/2. 2 over 2 is 1, squared is 1, equals, and then let's go ahead and go negative 1/2, and then this is going to be x plus 1, quantity squared, plus 2. Now bring this over, so f of x is equal to negative 1/2 x plus 1 squared, and then 2 over 2 times negative, or right here, 1 times negative 1/2, so I'm going to add a half, so it's plus 2.5. Now my vertex is negative 1 and 2.5. My axis of symmetry is x equals negative 1. Just solve that. All right, that takes care of A. Now we need to do B, where we're going to graph it, find the maximum, the minimum, the domain, the range, and the intervals where f is increasing or decreasing. So we need to think about how to graph this. Let me make a little bit of room. Okay, hold on. Okay, so when I graph this, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay, if I do just the parent one, right, which is going to be x squared. So x squared is here, and 2 and 4, 2 and 4, so this is my parent function, right? Now, I need to think about any shrinkage or anything. Well, I've got a negative 1/2 on the outside. So negative 1/2, the 1/2 is going to shrink the y values. So now I've got, I'm going to do this in blue. I've got my y value here, my y value here. This was at 4, it's now at 2. This was at 4, it's now at 2. At 3, it was at 9, it's now 3.5. So that gives me this one. Okay, now what I need to do, because remember we do this in order, so I need to reflect it because it's negative. That means it's going to go down. So let's stick with the blue. So now it was at, it's now going to be down here. And 1 and 2 and 2. So it's going to be something like this. And the final thing I need to do is pick up the whole thing and move it. I'm going to go up 2.5 and left 1. So I'm going to do this in black. So if I take my vertex now is at negative 1 and 2.5. Okay, take my point, go up 1, 2.5. And take this other point, and if I go up 2.5 and then over 1, which is going to bring it right here, take this point up, that's a half here, and over 1, and then go like this. Okay, that's my final graph. Now it says find the maximum or the minimum. We know it's going to have maximum because it goes down. So my max is going to be where f is -1, because remember that's going to be my vertex, and so it's going to be where x is -1, my max is at 2.5. Okay, the next thing I need to know is find the domain. The domain hasn't changed. It's all real numbers. My range is going to go from -infinity, starting down here, all the way up to where my vertex is at 2.5 included. Where is it increasing? It's increasing. Look at your x values from -infinity to wherever I get to that point, which is going to be -1 included, and then it decreases from -1 to infinity. Okay, that's it. Okay, here we go. Use the vertex form. So let's go do the vertex form first. So let's do A. So we've got f of x equals x squared minus 6x plus 4. So this is where we're going to switch it. I'm just going to take my f of x, leave it there. So f of x equals, now I've got x squared minus 6 plus something plus 4. So plus something. So it's going to be -6 over 2 squared. So this is going to get -6 over 2 squared. There's no number in the front, so we don't have to worry about that. So -6 over 2 is -3, so it's going to be 9 plus f of x equals, and then x, and -6 is going to be -3 squared plus 4. Bring my 9 over, so that f of x equals x minus 3 squared plus, oops, sorry, it's going to be a minus, isn't it? So squared minus 5. Vertex is 3, -5. Axis of symmetry is x equals 3. Okay, so now we need to graph it. So let's make some room. All right, let's make a graph. All right, here's my graph. So let's do the parent function first, which remember is just x squared. 2 and 4, 2 and 4. So it's something like that. That's the parent function. Okay, there's no shrinkage or stretching, and all I'm doing is just moving it over. So I'll go red, and the first thing I'll do is I'll just move it up 5. 1, 2, 3, 4, 5. So that means at 1 it's going to go up to here, and this one's going to go up to here, and that's up 4, so that's up here. So now I've got that one. Okay, that moves it up, and then I'm going to go right 3. So take this and go, let's do that in blue. 1, 2, 3. Take my next one. 1, 2, 3 goes there. Take this point and do 3. And then take this point and do 3. Take this point and do 3, so that we've got something like this. Okay, let's talk about, we knew that it had a minimum because the A, the thing that was in the front, is positive. So we have a minimum where at f of 3, which is -5, that gives me my minimum, right? That's my y value of my vertex. The next thing is my domain. Domain is all real numbers. My range is going to go from my lowest point, and my range is my y's, so look at your y's. So it's going to go from -5 to infinity. It's going to decrease right here, look right here. I'm going to decrease from -infinity to my vertex. So decrease from -infinity to my x value of my vertex, and then increase from, oops, included, my vertex to infinity. Okay, now we're going to find an equation. So let's think about our equation. The first thing I want you to think about is think about our vertex form. That's f of x equals a at x minus h squared plus k. All right, that's our vertex form. We have our vertex, so that means we can do this. F of x equals a x minus 3 squared plus negative 2, right? Okay, now we've got a problem. We need to find a, but we know we have an x-intercept of 4. So think about an x-intercept at 4. That's where x is 4, y is 0. So why not plug that in? This is my y, right? So I'm going to say that's 0. A, when my x is 4, sorry, wrong thing. When my x is 4, so now I've got 0 equals 4 minus 3 is 1 squared, so a minus 2, so a equals 2. So my final answer is f of x equals 2, x minus 3 squared minus 2. If I wanted to take it further and just put it into the standard form, I could say f of x equals, let's see, 2 times x squared minus 6x plus 9 minus 2. Therefore, the final answer would be 2x squared minus 12x plus 16. I could do either form, vertex form or standard or general form.